I want to acknowledge something about the sort of science that I do. When most people think science, they think something like this. They think lab coat and gloves and expensive instrumentation, pipetting, controlled experimentation. As great as that is, as many wonderful things as you can learn with a controlled experiment, let me just say that in some fields of science, it's a little bit more like this. Most people don't think of science as having anything to do with going to Vegas and hitting, the craps tables. But it is true that some kinds of science are like that, and I say, welcome to the wonderful world of paleontology. Because no matter how prepared you are, no matter how ambitious you may be, no matter how badly you want to find that amazing fossil, you might, but more likely you won't. This was March of last year, and I was hiking through this field of boulders with my crew, and we were on our way somewhere else. And I said, hey, listen, as you're hiking, be sure and keep your eyes peeled for fossils. We've never really looked at these rocks, and you can find fossils in the sandstones. These are sandstone boulders. And I said, so you want to look for something like, and I looked around for the nearest scrap of bone sticking out of a sandstone boulder. I said, something like this. And I went, wait a minute. And I leaned in close, and the undergrads who were with me tell me that I cannot repeat what I said to you next. Because as I looked into this tiny, tiny fossil on a boulder, what I saw was this. Here it is, coming out of the boulder. Here's the close-up for you. This is the top of a primate skull. And so what we have here are the two eye sockets. This is where the nose starts. This is the beginning of the brain case. And it's tantalizing, right? It's just the tip of the iceberg. And I was like, oh, the rest of the skull is in there. I was high-fiving Sarah Wilson, who's here in the audience. I was like, high five, I found something as cool as your grandpa. And our somewhat taciturn preparator, who's from Germany, said, well, I'm not so sure. And I said, what do you mean? Look at the skull. And he said, sometimes they fall apart in the sandstones. And I was like, oh, don't be so negative. We're going to get this back to the lab. We're going to prep it out. It's going to be the best fossil anybody's ever found. I could probably just retire now because I'll never find anything that cool again. Well, it was good luck to find it. But as they say, the paleo gods giveth and the paleo gods taketh away. I'll tell you what, I'll take this even though it is just the front of a skull. Sebastian was right. Everything else is missing. What you see here is the forehead, the front of the brain case. These are the eye sockets, the orbits. And I know it's a primate based on its anatomy. Oh, but I don't have any teeth. And I won't know what species this is until I find some teeth from the same sorts of areas. So here's what you need to find fossils. There's no escaping the fact that you have to have some measure of good luck, number one. Of course, it helps to have some training. It helps to be persistent. It helps maybe even more to have some money. But as in other fields of science, you need giant shoulders to stand on. And I have a picture of John Andrew Wilson here because these are the giant shoulders that I stand on in my paleontological fieldwork. And it was in the 1940s that he came to the University of Texas as a young geology professor. And he, among other things, he founded UT's Vertebrate Paleontology Lab. This is the most important paleontological repository of record in the state of Texas. This is where all of my fossils that I find in my fieldwork are curated. And if you're wondering why there are so many great Eocene-aged fossils in this part of Texas, the answer is, of course, geology. Hooray for geology. The Big Bend is absolutely filled with ancient volcanoes. This period of Rocky Mountain building, towards the end, what you see is a whole bunch of volcanoes popping up. So essentially, all over this basin, you've got volcanoes. And the volcanoes really start in the Middle Eocene. And here's the great thing about volcanoes. Some of you more savvy, geology-informed people are no doubt thinking, I don't think that hot lava is a great way to preserve fossils. And you're right. But if there's one thing that volcanoes are really good at doing, it's burying stuff. Volcanoes produce tons upon tons upon tons of sediment. And this sediment, right, it's erupted out as ash and rock fragments and things like that. Here's an eruption happening. And all of this sediment, mainly ash, is going to be redistributed by rivers. It has to go somewhere. And when you have a great big slurry of this stuff coming down a river valley, it's called a lahar. So here's some poor house, I think in Chile, that got buried by a lahar. But you have this great combination of a sedimentary basin that wants to trap sediment and a source of volcanoes in the Eocene that are providing the sediment. And it's that material that all of the fossils are preserved in.